Again, we got in terms of the unit circle and given an x value, can we determine the y value that goes with x? Now let's see how good everybody is. So if I give you this. Given x is 3/7. What would be the y value? Right? Again, in terms of a fraction. Not a calculator answer, we want a fraction. So the exact answer, this.
Same.
Yeah, same deal. Yep. So the same deal we just did, right? This time, given x is 3/7, what is the corresponding y number? In this case, the y number doesn't come out quite as nice as my first one did. Okay. Not quite a nice number, right? You're online. You're able to read that all okay? What I wrote?
Yes.
Okay. All right. All right. And I am recording, right? So this recording will get posted later today. Okay. So again, each time the Zoom sessions will get posted. Okay. And this one, the numbers don't quite work out quite as nice as the one I first gave you. The fractional answer. Okay. I'm going to get the decimal equivalent here for the exact answer. Huh? Nope, that kind we don't want the decimal. I want the exact answer. So you're gonna have to do. You put it in the calculator, you can get a decimal equivalent, but I want exact. Again, when you do the homework on Cengage and all that sort of stuff, you want to pay attention to how it says it wants the answer, right?
I thought it's still on the thing.
Huh?
For the on that.
No, it's not WebMap this time.
Oh.
Different software this time. But again, pay attention to those things it tells you in there about how it wants the answer, because again, that's what it's going to be looking for. Right. So if it says it wants the exact answer and you type in, the calculator answer, it'll mark you wrong. Okay. One of those kind of things it tells you. All right. Again, I want to take my number and we're going to plug it in again. This time, you don't quite get, it's not a nice number this time, like the previous one, but you should be able to still be able to deal with this. Right. After all, 3/7 squared is going to be 9 over 49. And again, we want to subtract. And again, we can rewrite this as 49 over 49. The y squared is going to be 40 over 49. And I want to get this out of the way just so I can bring that up higher and make it easier for the people in the back to see. We have y squared equals 40/49. Again, the opposite of squaring is to find the square root, so y is going to be plus or minus the square root of 40/49. Again, we're now looking for the, plug it into the calculator number for this. And so I gotta deal with this 40/49 thing. So let's bring that over here for the moment. I can rewrite this like that. Okay. What is the square root of 49? 7, all right? So that means I now have the square root of 40/7, all right? We got that part. But now we got that top part, okay? And we want to simplify our radical, okay? We want to simplify the top part, right? So you think about those numbers that have nice whole numbers, square roots like 4, 9, 16, 25, 36, 49, so on and so on, right? And you look at and you say, okay, what would be the biggest number off of that list that would divide into 40 and give you a whole number answer? 4, right? So I can rewrite the 40 as the square root of 4 times the square root of 10. And then the square root of 4 is 2. And so we get 2 square root 10 over 7, right? Right. So that would mean that in terms of what are the possible points, we would have one point would be 3/7, 2 square root of 10 over 7. And then the other point is 3/7 minus 2. So radicals and simplifying. So again, you think about that list of numbers I can rattle out that have nice whole number square roots. Okay. Ready to go with that one? Ready to go with simplifying radicals? So in terms of a circle, and what your book uses in terms of notation. Now really it talks about, it calls this in terms of the terminal point, okay? In terms of its notation, they use it. And then you have in terms of how do we measure angles? Well, there's 2 ways of measuring angles. There's degrees and there are radians. Right? So in terms of degrees, number 0, this is 90, 180, 270, and then 360. Okay. And then in terms of how we do this, we have that going this way is the positive direction, and then going this way is the negative direction. Right? So that's the measurements of those angles in terms of degrees. But you're going to see a lot here in this course, and especially when you get to calculus and you're doing trig functions, that everything is done in radians. So 0 degrees is 0 radians. Everybody remember the formula for circumference of a circle? Yep.
I times the diameter.
What?
I times the diameter.
And what's the other formula of that?
2 times pi times.
Right. C equals 2 pi r, okay? And circumference is the measurement around the outside of a circle, right? What circumference is, right? Right. And so the measurement, if I go all the way around the circle, that angle is 2 pi. So 360 degrees is 2 pi radians, right? So if 360 degrees is 2 pi, what would 180 degrees be? Pi. Right. So if 0 degrees is 0 radians, 180 degrees is pi radians, what would 90 degrees be? Right. Half a pi. And we write that as pi over 2. Okay. 90 degrees, right? So 180 degrees is 1 pi, 360 degrees is 2 pi. And so 270 degrees would be 3 pi over 2. Just got it. So you have in terms of how the angles are measured in radians. Okay? And then you have in terms of the terminal point. Well, here, this is the point 1, 0. Here, if it's at 90 degrees or pi over 2, this would be the point 0, 1. If it was pi radians, we're over here, and we're at -1, 0. And if it's at 3 pi over 2, we're here, which will be 0, -1.
The pies are did you see the degrees?
So there's a table in your book, there's a table in my notes about certain angles, and there's a few of them. So 0 degrees, which is 0 radians, which would be this point over here, which is the point 1, 0. And then there are going to be several different angles where you're going to need to know what is the exact values. Okay? And so you have in terms of 30, 45, and 60 degrees in the order. So 30 degrees, which would be the same thing as pi over 6. You have the square root of 3 over 2 and 1/2 for that one. 45 degrees, which in terms of radians is pi over 4, is the square root of 2 over 2, square root of 2 over 2. $60 degrees, which would be pi over 3. And that one is barely the opposite of my 30. And then the other ones are my quadrant angles. We have 90, which is pi over 2, which was the point 0, 1. We have 180 degrees, which is pi. -0. And then 270. 3 pi over 2. 0, -. So you have that chart. Again, some of those you didn't even know, okay? In terms of exact numbers, all right? So 30 degrees, pi over 6, pi over 4, pi over 3. Your book for the angle uses the letter T. So we'll use that for that angle there. Yep. So in terms of my trim functions and what they would be on my unit circle here, right? So you have our basic 3, which are sine, cosine, and so sine is the opposite over the hypotenuse. So if here's my angle, this is the opposite, y, and my hypotenuse is 1. And so the sine of t is going to be y. After all, y divided by 1 is just y. Right? Cosine is adjacent over hypotenuse. And so here's my angle. This is the adjacent side, which is going to be given by x. And again, my hypotenuse is 1. So cosine would be x. And then tangent is opposite over adjacent. So this is the opposite. This is my adjacent. And so my tangent of t is going to be y over x. This person, although. So those are the basic 3, but there are another 3, and the other 3 are reciprocals of the first 3. And so we could have cosecant, which is hypotenuse over opposite, which in this case would be that cosecant of t is going to be 1 over. And then for cosine, we have secant, which is hypotenuse over adjacent. Secant t is 1 over x. And then tangent, we have cotangent, so this is going to be x over y. Those are the true functions: sine, cosine, tangent, cosecant, secant, and cotangent. Right? All right. So, given that those are my trig functions, and what they are in relationship to x and y, which trig functions are positive in the first quadrant? Which trig functions are positive over in this first quadrant?
All of them.
All of them, right? Because after all, in this quadrant, x and y are both positive. So all are positive here. Right. How about in the second quadrant? Which trig functions are positive? Second quadrant.
None of them?
Y is positive.
Y is positive, so which means which trig functions are positive?
Sine, cosecant.
Sine and cosecant will be positive. After all, in that quadrant, y is positive, right? How about the third quadrant?
Cotangent.
Tangent and cotangent will be positive, okay? After all, both x and y will be negative, and then negative divided by a negative will be a positive, right? And then lastly, in the fourth quadrant, you would have cosine and secant. After all, in this quadrant, you have x is positive. Okay? So we have in terms of our sign values of our trig function. Everybody remembers domain and range? So let's finish off with the domain. Again, this is from 5.1. I do have the video up on all this. There's some of these pages I did skip, but you'll find on the original video. Okay. But here's sine. Sine t is given by what? So what angles can I take the sine of? So, but some of you have your calculators in front of you, and you probably again on your calculators, okay? So when we start playing more with this stuff, the mode of your calculator is going to be important, okay? But if I ask you to do something like what is the sine of 5,000 degrees, you should be able to plug it in and get a number. If I ask you to do the sine of 0, you should be able to plug it in and get a number. I ask you to find the sine of negative 10,417,583 degrees. You'll be able to find a number, okay? So my domain here is I can find the sign of any angle I want, right? So my domain for this is going to be all real numbers. It's going to be the same thing for cosine. I can do that of any number, okay? This is also all real numbers, okay? Doesn't matter, right? Now, when we get to the other ones, however, we do start having things that have to be excluded because after all here, tangent is y over x. Which means, okay, here I'm okay, because x is a number, but here I have a problem. Because here x is 0. Here I have a problem, x is 0. Okay? So I start having problems at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. So we start having restrictions when I get to here. And so this is going to be all real numbers. Other than n pi over 2 and pi over 2 for every integer. Right. So we start having problems at those numbers. So whenever I have the x here, so that means this restriction here is also going to be the same restriction when I get to secant. The secant also has the x in my denominator, okay? Now we get to cosecant and cotangent. Well, cosecant and cotangent have a y in the denominator, which means I have a problem here at 0. We have a problem at pi, at 2 pi, 3 pi, so on and so on, right? So this one also will have restrictions. So again, it'll be all real numbers other than n pi or any integer n.
Oh, it's supposed to be pi, okay.
Any integer n. We need to get that in there. No, any integer n, because they always have pi.
And then that's pi over,
Pi over 2.
okay.
Really, again, pi, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, so on, right? Oh, all right. Again, the whole video from 5.1 is up, so again, I skipped some of the pages for today. But it is there. And the expectation then is you'll watch the video for 5.2. Right? Do a few problems in the class, and then after that, there'll be a group quiz. Be about probably about 3 problems or so on the group quiz. You get to work with your neighbors or you, right? And we'll see everybody again on Thursday. Again, this video will be posted later today.